So far in Algebra 2, we've done systems of 2 equations and inequalities, but this lesson is about solving systems of 3 equations. So in order to solve a system with 3 variables, you need to have 3 equations. So I took this from Math Warehouse, this graphic right here. This is showing what can happen when 3 planes intersect. Or not intersect. So 3 planes can intersect in a line. So if you think of all the points on the line, there's an infinite number of solutions. 3 planes can intersect at exactly 1 point. Or 3 planes can never intersect. They can be parallel and have no solutions. So these are different solutions that you can have: no solution, 1 solution, or infinite solution. Same thing with a line. So the reason that we have planes is because, remember from geometry, that 3 points make a plane. So we're not talking about 3 lines intersecting, we're talking about 3 planes intersecting. So in order to solve a system of 3 equations, you can do substitution, or you can use elimination. So what I'm going to do elimination-wise is I'm going to take 2 of the equations and eliminate a variable, and then take 2 of the other equation and eliminate a variable. So I'm going to be left with a red equation that's in 2 variables and a blue equation that's in 2 variables. So I'm going to do the red first. So if I look at these two, a variable that I can see that I can eliminate offhand just by adding the 2 equations would be the y's. So if I eliminate, actually, and the z's, so if I add these two together, these will cancel out, and I'll get negative 4x equals 16. So then x equals negative 4. So that's part of what I know, is x equals negative 4. Now I can look at the top, the 2 blue equations that I highlighted, and I'm going to eliminate the y's. So I'm going to eliminate the y's by making all the signs opposite for the top equation. So it's going to be 4x plus 5y plus z equals negative 18. So I'm going to take these 2 equations, this equation and this equation, and add them together and get a new equation. So it's going to be 4x and negative 2x adds up to 2x. The y's will cancel out. And then I'll have z minus 2z. So it's minus z equals negative 18, and 12 adds up to negative 6. So if I know that x equals negative 4, I can plug negative 4 in right here. So it's going to be 2 times negative 4 minus z equals negative 6. So negative 8 minus z equals negative 6. Negative z equals 2. Z equals negative 2. So I have x and I have a z, and all I'm missing is a y. So to get the y, you can substitute into any one of these equations. So I'm going to use the last one, and I'm going to put my x in. So I have negative 2, and my x is negative 4, plus 5y, plus 2 times negative 2 equals 4. So I'm going to simplify this and get 8 plus 5y minus 4 equals 4. So if I add 4, I'll have 8 over here, and I'll have 8 on both sides. So I can subtract 8. So 5y equals 0, y equals 0. So I want to write my ordered pair as x is negative 4, y is 0, and z is negative 2. So go x, y, z. So let's look at this next one here. So So we have three equations and three different variables again. So what I'm going to do is I'm going to circle or box these bottom two in, and I'm going to eliminate the y's. So if I add these two equations together, I'm going to get negative 3x plus 2z equals negative 5. So I took two of the equations and eliminated the y. Now I'm going to pick two more equations, just a different combination, and eliminate the y. So I'm going to use actually the top one and the bottom one, because I can eliminate the y's again, because this is a negative 5y and this is a positive 5y. So if I add the first equation and the second equation, I'm going to get negative x plus 2x is x. The y's will cancel out, and I'm left with negative 2z equals 17 minus 10, or plus negative 10 is 7. So now I have a system of two equations, and you can solve this by substitution or elimination. This one I'm just going to eliminate the z's. So I'll get negative 2x equals 2, so x is negative 1. So if I have x is negative 1, I can take this x is negative 1 and plug it back into this equation. So it's going to be negative 1 minus 2z equals 7. Add 1. So negative 2z equals 8. Z equals negative 4. And now I can take x and z and plug it into any of these equations to get y. So I'll use the first one. So it's going to be opposite of x, so positive 1, minus 5y plus negative 4 equals 17. So negative 3, add 3 to both sides, so it's 20, so negative 5y equals 20, y equals negative 4. So you want to write it as an ordered pair. The x first, then the y, then the z. And when you're doing these, you want to make sure, especially on a quiz or a test, that you're going to go back through and plug in x, y, and z, and make sure they fit x, y, and z into all three equations. So these three planes intersect at a point, negative 1, negative 4, negative 4. Okay, a couple more examples here. So if I look offhand, I know that an easy way would be to eliminate these a's right here. I could do the a's. So I can cancel this out, so I have 6b plus 6c's equals 3. So now what I want to do is I want to eliminate the a with two other equations, two other combinations. So I'm just going to do the first one and the second one. So I'm going to multiply both sides of the equations by, this one I'm going to do 4, this one's going to do negative 5, because I want them to be opposite. So I'll write those in blue. So I'm going to have 20a plus 20b plus 20c equals negative 80. Then I'm going to have negative 20a minus 15b minus 15c equals 30. So now I'm going to add these two together, and I'm going to be left with 5b's plus 5c's equals negative 50. So I have these two equations right here. 6b plus 6c equals 3. 5b plus 5c equals negative 50. So I'm going to solve this system for b and c, and I can substitute it back in to get a. So I'm going to eliminate the b's. So I'm going to multiply this by 5 and this by negative 6. I'm going to copy it down here. So it's 30b. You can see how you have to be super organized on this. Equals 15. In the bottom equation, 30b minus 30c equals 300. Ooh, the b's cancel out and the c's cancel out. So I have 0 equals 315. So you remember that if you have the left-hand side not equal to the right-hand side, after your variables have been canceled out, it's going to be no solution. So what this means is it's three planes that are never intersecting. Okay, I'm going to slide over to one over here. So you can look at, I'm going to cancel out the y's use these two right here, and I'm going to eliminate the y. So I'm going to multiply this top one by -2. Both sides of the equation by -2. So it's going to be positive 6x minus 2y minus 10z equals 10. I can add these two together and I get a new equation that the y's are gone. So it's going to be 2x minus 9z equals 23. So I eliminate the y, I've eliminated the y. So then I need to look at a combination of two other equations that I can eliminate the y. So I'm going to do these top two. I'm going to multiply the top one by a negative, or the bottom one, this one right here, by a -3 in order to get these y's to eliminate. So it's going to be, I'll write it over here, so it's going to be 9x minus 3y minus 15z equals 15. And I'm just going to copy this top one over here, -5x plus 3y plus 6z equals 4. Because I'm going to add these two together, and it's going to eliminate the y's. So it's going to be 4x, the y's cancel out, -9z equals 14. 15 plus 14 is 19. Okay, now I have a system of two equations and two variables. So I'm going to multiply the top by a negative, and I'm going to add these two together. So it's going to be 2x equals -4, x equals -2. So now what you can do is you can plug in x equals -2 into one of these blue equations and get z. So I'm going to use this one. So it's going to be 4 times -2 minus 9z equals 19. So -8 minus 9z equals 19. Add 8, -9z equals 27, z equals -3. So now you can take your z equals -3 and you can plug it back in up here into one of these equations. I'm actually going to plug everything back into this one right here to get my y. So it's going to be -4 times x is -2, plus 2y plus z equals 13. So this is going to be 8 and -3 is 5. Subtract 5 from each side. I have 2y equals 8, y equals 4, and at the end you want to write it as an ordered pair: x, y, z.